My name is Walter Unglaub, and this is how to write a standard form of an equation given the ends of a diameter. So the standard form equation is the equation that describes a circle, and it's given in terms of x and y, as well as the coordinate of the center of the circle, in this case x naught comma y naught. So we have for the standard form x minus x naught squared plus y minus y naught squared, and this is all equal to the radius of the circle squared. So if all the information that we're given are the coordinates associated with the endpoints of the diameter, I have, for example, at this point, point A coordinate x1, y1, and at this point, point B, I have, say, the coordinates x2, comma y2. So the first thing I need to do is derive what this radius is. In order to do that, I'm going to use the distance formula. So the distance formula, in this case, it would be the length of the diameter in terms of these two coordinate points, is given as d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Since we know that the radius is actually half of the diameter, we know that the radius will be given by this entire expression divided by 2. So this is going to be the radius r that I plug in to my standard form. Then all we have to do is calculate what the coordinates are associated with the center of the circle. In order to do that, I have to recognize that the slope is actually equal to the tangent of this angle theta. I can calculate the slope m by looking at the difference in y divided by the difference in x, and that's going to be equal to y2 minus y1 divided by x2 minus x1. So if I set this equal then to tangent of the angle theta here, then I can solve for this angle in terms of just what's given to me, which is the values of these coordinates. So my angle theta is going to be equal to arctan of my slope, which is y2 minus y1 divided x2 minus x1. Now that I have this angle, I can recognize from the trigonometric relationship between x and y and the angle by how much I should add to x1 and y1 in order to move this length here and this height here. So I have an equation then that I can write down for x naught and y naught. And that set of equations is x naught is going to be equal to x1, the original point, plus the radius times cosine of the angle, which I calculated from the slope, and y naught is going to be equal to y1 right here plus r, which serves as the hypotenuse in this case for this little triangle, times sine of theta. So now I have derived an expression for x naught and y naught in terms of information that was initially given to me, and theta, which was also derived from the initial data, the coordinate points that define the endpoints of this diameter. And I have an expression for the radius, which is the distance formula divided by 2. So, since I have everything, I simply write down the standard form here, and I can substitute these expressions in terms of in place of r, x naught, and y naught. So, again, given just the coordinates for the ends of diameter, I have the full equation for the circle in terms of these relationships. My name is Walter Unglaub, and this is how to write a standard form of an equation given the ends of a diameter.